Hey guys, welcome to CPM 3. This is Module 4, Lesson 2 and 3, Part 2. So in Part 1, we went over your substitution method and your addition method of solving linear equations. So this lesson we're going to be applying. So if you missed last lesson, you need to go back to the last video and rewatch it. And so because we're going to be using this in word problems, here's kind of some helpful steps into solving word problems. First, understand the problem. So if that means you have to read and reread the problem, do so. You can't solve the problem unless you know what it's telling you and what it's asking for. This one is a very big one. You need to choose a variable to represent the unknown. That makes it easier later on in this process. You need to translate the problem into two equations, solve the system of equations, and it doesn't matter which method. So you can either use substitution or addition. And so I'll try to do a combination of both of them in this video. And then interpret the results. So state your conclusion and check your answer. If you choose a variable to represent the unknown, it makes this portion here a lot easier. Okay, so we have 4 different types of problems. We've got break-even problems. We're going to do 2 examples. We have written problems. We're going to do 2 examples. We have value problems. We're going to do 2 examples. And then we're going to do current problems, and we're going to do, you guessed it, 2 problems. We've got 8 problems total to do here. I've kind of set this up where it starts out with the easiest type of problem and it kind of works its way up to the hardest types. So in my break-even problems, example 1 says, given the cost function C of X and the revenue function R of X, find the number of X units that must be sold to break even. When they want you to find that break-even point, that break-even point in your business model is when your cost, your C of X, equals your revenue, your R of X. Which should make sense, right? If your cost, what you're putting into your company, equals the revenue, what you're bringing into that company, as long as you are bringing in the same amount you are putting in, then you are breaking even. If your cost is more, then you are losing money. If your revenue is more, that's when you're getting rich because you're making money. So when it wants that break-even point, we are basically setting this equal to this because that's my C of X and my R of X. So we have 1.2x plus 1,500 equals my revenue 1.7x. So this one actually has nothing to do with systems. Just set these equal to each other and solve for x. So I need to get x on the same side. So we'll subtract over our 1.2x. That cancels, and I'm left with 1,500 equals 0.5x. Divide both sides by 0.5. And my x equals 3,000. So remember, word problems require word answers. So the company must sell 3,000 units to break even. Okay, so this is my final answer. Now let's try this again, but in this one, they don't really set anything up for me. They don't tell me what it equals, my R of X and my C of X. We've got to figure that out. So example 2 says the planning Department of Abstract Office Sales has been asked to determine whether the company should introduce a new computer desk next year. The department estimates that $7,000 of new manufacturing equipment will need to be purchased, and that the cost of constructing each desk will be $150. The department also estimates that the revenue from each desk will be $500. So, A says determine the revenue function R of X from the sales of X desks. Sorry. Whew. Okay. So here's where they're talking about my revenue. So my revenue, R of X, equals, if I'm getting $500 from each desk, and we're going to call desks X, that is 500X. Each desk is 500. So then my cost revenue says the cost of constructing each desk will be $150. But I also have to buy new manufacturing company of $7,000. So my C of X equals 150X, 150 for each desk, plus that one-time $7,000 fee for that new equipment. So now part C says find the number of desks that must be sold to, again, break even. So set your revenue equal to your cost. So I have 500. That looks no better, does it? 500X equals 150X plus 7,000. So solve for X. You need to get X on the same side. So I'm going to subtract my 150X over. So I get 350X equals 7,000. Divide both sides by 350. And I get my X to be 20. So again, word problems require word answers. So, So the company must sell 20 desks to break even. All right. So those are your break-even problems. So let's turn the page. Now we have some written problems. Example 3 says, write a system of equations modeling the given conditions, then solve the systems by the substitution method. And then find the two numbers. So, in my first one here, the sum of two numbers is 99. Well, I don't know what these two numbers are, but I know they're two probably different numbers. So my first equation here is x plus y equals 99. I know when I add these two numbers, it's going to equal 99. So whether that's 60 plus 39, 40 plus 59, whatever the case is, when I add these together, it needs to equal 99. Then it tells me that one number is more than the other. Really doesn't matter which is which. So if I say my one number here is x, then my x equals, how do you represent 37 more than the other? It would be y plus 37. So whatever y is, I'm adding 37 to it, and that gives me x. So let's solve. because this is already solved for x, we're going to plug that into the first one technically. So in place of this x here, I now have what x equals. So we have y plus 37 plus y equals 99. So in place of this x here, we put in y plus 37 because that's what x equals here. So now solve for y. So y plus y is 2y. So 2y plus 37 equals 99. Subtract your 37 over. And I get 2y equals 62. Divide by 2. And my y equals 31. So now that I have y is 31, we're going to plug that in. So in place of this y, we now have x equals 31 plus 37. So my x equals 68. Word problems require word answers. So the numbers are 31 and 68. And I like these kinds of problems because these are really easy. You can check this. Does 68 plus 31 give me what I need? Will we get 99? So yes, that does check out. Example 4, again it says, write the system of equation modeling the given conditions and solve the system by the substitution method. And then find the two numbers. So the difference between two numbers is 3. So I know when I subtract x minus y, we get 3. Then it says the sum of the larger number okay, I had to read that. Sorry. The sum of the larger number and 5 times the smaller number is 33. So let's kind of talk about that for a second. If I have x and y, when I am subtracting, in order to get a positive 3 here, that means this one needs to be your bigger number. So this x represents my larger number. So then y is my smaller number. Okay, and it has to be that way. Otherwise, this would be a negative if it was reversed. So, I'm going to scoot this over. Okay. So now, the sum means add of the larger number. So I've got x plus, and then 5 times the smaller. So plus 5y is my equal sign 33. So now solve. Now they're telling me to do this by the substitution method. They're really not going to know how you solved this, so just solve it any way you want. I'm going to go ahead and go with the addition method. So I've got a negative y and a positive y, so I can cancel those out pretty easily if I multiply this top one here by 5. So now I have 5x minus 5y equals, don't forget to multiply this by the same thing, equals 15. So now my y's here cancel. And I'm going to add what's left. So x plus 5x is a 6x. And 33 plus 15 is 48. Divide both sides by 6. And I get an x to be 8. So now I'm going to take this first equation here and substitute it in. So now I've got 8 minus y equals 3. Subtract your 8 over. Now be careful here. Once I subtract my 8, I'm not left with a y, I'm left with a negative y. So I've got negative y negative y equals 3 times 3 minus 8 is a negative 5. Divide by negative 1. And my y here is 5. So what are my two numbers? My final answer is the numbers are 5 and 8. Okay, so those are your written problems. We've got two more types. On the next problem, we have our value problems. Now, these value problems, you will have a test question that is over these value problems. So we do need to get good at these. So example 5 says the OCCC bookstore paid $15.15 for an order of 44 calculators. The store paid 10 for each scientific calculator and 53 for each graphing. How much of each type of calculator was ordered? So you need to define your unknowns. We're going to let scientific calculator be my S. And we're going to let my graphing calculator be my G. Now, if you want to go with X and Y, that's fine. But sometimes it's hard to remember, okay, what did I make X and what did I make Y? But if I use S and G, I know S is for scientific, and I know G is for my graphing. So the first equation needs to just be over the amount I have. We have ordered 44 calculators of some combination. So my first equation here is S plus G equals 44. So whether that's 24 and 20, 14 and 30, whatever that combination is, I know when I add up the number of scientific and the number of graphing, it needs to equal 44. So your first amount's just over the number. Second one has to do with the money. So how much did we spend for scientific calculators? We spent $10. So I have 10S plus we spent 53 for graphing. So plus 53G equals, and then how much did I spend total? I spent $15.15. Okay, so one has to do with the amount and one has to do with that money. So now solve. So you can either solve by substitution or by elimination. We'll do this first one by substitution, and we'll do the bottom one by elimination. So here, if I solve for one of these, G or S, because they both have a coefficient of 1, let's say we go with G. I'm going to get G equals 44 minus S. Okay, so down here, I'm just subtracting that S over. I can't combine these, so we're just putting them side by side. So you're just subtracting S over to the other side of the equation. So now that I have that, now substitute into this one, and we're going to substitute it in for this G. So I've got 10S plus 53 times 44 minus S, and then equals 1515. So distribute your 53. I've got 10S plus 53 times 44 is 2,332. 53 times a negative S is negative 53S equals 1515. So I'm going to do two different things here since I'm sort of running out of room. I'm going to combine like terms. When I combine like terms, I am going to get a negative 43S. And then I am also going to go ahead and subtract this over. So, let me scoot this over again. So I've got negative 43S when I combine my 10S and 53S equals, when I subtract right here, I get a negative 817. Divide both sides by negative 43. And I'm going to get S equals 19. So now that I have my S, plug it in. We can plug it into this equation, but I'm going to plug it into this one because it's already solved for G. So now I have G equals 44 minus 19 to get G equals 25. So word problems require word answers. So OCCC ordered 19 scientific I'm going to abbreviate calculators and 25 graphing. So let's try again. A jar contains N nickels, so they're telling me what nickels equals, and D dimes. There are 20 coins in the jar, so let's make an equation just over the amount we have. I know my nickels plus my dimes needs to equal 20. So whether this is 10 and 10, 11 and 9, 5 and 15, whenever I have them, they need to add up to a total of 20 coins. Then it says the total value of the coins is $1.40. So let's put one with our money. How much does a nickel equal? That's 5 cents. Now be careful here. A lot of people put 5N, 0.5N, but that 0.5 is the same as 0.50N. That's 50 cents. So for my dime here, this needs to be 0.05N. Plus, my dime is 10 cents. So either 0.10, but you don't really need that 0, so 0.1D equals $1.40. So again, One of these is the amount of coins, and one of these has to do with the money. So, solve. This one we solved by substitution. So we can solve this one by elimination. So, in order to get this 0.1 to equal my D, we need to multiply that by 10. And in order to make this cancel, we need to multiply it by a negative at that. So I'm going to keep this top one, but now this one here, let me get out my calculator. All right, 0.5 times 10 is 0.5n. 10 nickels equals 50 cents. And that will be negative. Negative 10 times 0.1 is a negative 1, so negative D. And negative 10 times 140, you're basically just moving that decimal place over 1 in all of these. So this equals negative 14. So now my D's cancel, and I'm going to add what's left. So 1 plus a negative 0.5 is 0.5n equals 20 minus 14 is 6. And now divide by that 0.5. And we get n to equal 12. So now plug that in. Easiest one to plug this into is this top one. So we have 12 plus D equals 20. Subtract that 12 over, and we'll get D equals 8. So, word problems requires word answers. So, the jar contains 12 nickels and 8 dimes. All right, and last one, last type anyways, is your current problems. So these are honestly the harder of the two, but you're also going to have one like this on your test. Okay, you're going to have two types of word problems, these current problems and then the value problems that we just did. So, an airplane took 4 hours to fly 1,200 miles against a headwind. A headwind, okay, you have a little diagram here. A headwind right here is when that wind is going against the head of that airplane. The returning trip with a tailwind, so same thing, now your tailwind is the wind going into the tail, took us 3 hours. So find the speed of the plane in still air and the speed of the wind. So this diagram does a lot for us actually. It tells me that we're going to call P, my plane speed, and W, my wind speed. So when I have a headwind, okay, let me back up there. So now that I have my plane is P and my wind is W, for these problems, and it's not going to be given to you, you have to memorize this. You're going to have to memorize your distance equals rate times time formula. So when I am in a headwind, told me here, my headwind, we flew 1,200 miles. So my distance here is 1,200. Oops. Okay, equals your rate in a headwind is going to be this P minus W. Okay, your plane speed minus the wind speed, because that wind is hurting you, minus the wind because it's going against you, times my time. How long did it take me to fly? 4 hours. So then do the same thing. The return trip, so if I'm returning, my distance is the same amount, equals, now when I have that speed going with me, that speed is going to help me, so it is a P plus W. And how long did it take me? 3 hours. Okay, so my headwind equation is 1,200 equals P minus W times 4. When you look at this problem, even though that 4 is behind, it's very tempting to go through and distribute. But instead, and I'll show you why this works so well, I actually want to move that 4 away from that P minus W. So how do you move this 4 to the other side of this equation? Well, distributive property is just multiplying, right? We would do 4 times P and 4 times a negative W. So the opposite of multiplying everything by 4 is to divide by 4. So 1,200 divided by 4 is 300. My 4's here cancel. And so I am left with a P minus W. Let's do the same thing for my tailwind. So I have 1,200 equals P plus W times 3. Now again, it's tempting to distribute that 3, but opposite of multiplying P and W by 3 is to divide. So I'm going to divide that over. 1,200 divided by 3 is 400. My 3's cancel, so I'm left with a P plus W. So now I'm going to take this equation here and this equation here, and I'm going to stack them. So I have 300 equals P minus W, and 400 equals P plus W. The whole reason I did that is because your rate is always going to be like a P plus and a P minus W. When I move that time to the other side, now I've got a negative W and a positive W. Those already cancel each other out. So now I get to use elimination and solve. So 700 plus 400, or sorry, 300 plus 400 is 700. And P plus P is 2P. Divide both sides by 2. And I get my P is 350. So then take one of these equations. So I could take this original one, or one of these. I'm going to take this small one with all positives, I've got 400 equals my plane is 350. Let me write this a little smaller. $350 plus W. Subtract the 350 over. And now I get my W is 50. So word problems require word answers. So what did we find? We have found that the plane's speed is 350. What unit are we in? We have miles and we have hours. So miles per hour. And the wind, that's a 5. The wind is 50 miles per hour. Okay, now let's try again down here, but this time I now don't have this box and this diagram. This time we have a boat. A boat travels 5 miles upstream in 5 hours. So, if I'm using my distance equals rate, distance equals rate times time. I am going 5 miles, so that is my distance. I'm going 5 hours, so that is my time. And now what is my rate? Well, let's go ahead and call the current C and the speed of my boat B. So if I am going upstream, that means I am going against the current. If I'm going against the current, then that is hurting me. So it's my boat speed minus that current. Now it says going downstream. So downstream, now that current is helping me. So B plus C. And I can travel 55 miles. So that is my distance. In the same amount of time. So 5 hours. So solve. So I want to get this time to the other side of my equation. So in order to do that, on this first equation, I'm dividing everything by 5. So now I have 1 equals B minus C. Do the same thing over here. I'm going to divide by 5. My 5's cancel, my 5's canceled there. Divide this by 5. And now I have 11 equals B plus C. So now my C's cancel. And I'm going to add what is left. So 1 plus 11 is 12. B plus B is 2B. Divide both sides by 2. And I get my B to be 6. So now plug that in. I'm going to plug this into one that has everything positive. So I've got 11 plus, 11 equals 6 plus C. We're going to subtract over our 6 to get C equals 5. So again, word problems require word answers. So the boat's speed is 6, and we are again going miles an hour. So miles per hour. And the current is 5 miles per hour. All right, that's all I've got for this lesson. So as usual, rewind this video and pause it as much as you need to. You want to pay attention to these 2 current problems as well as these 2 value problems, because you will have test questions that are these types. You will have, I don't know what I'm doing here now. And I messed something up. There we go. And you will have the written problems and these break-even problems in your homework in my math lab. So, let me know.